To design a finite automation that accepts binary strings with even number of zeros. So here we can check whether the finite automata accepted only even number of zeros. They won't bother about number of ones, whether it started with ones or ended with ones or any number of ones maybe. But the string consists of even number of zeros over and the binary strings 0 and 1. So first we have to write what is language derived by this problem. So it may be even number of zeros, 2, 0 maybe, 1, 2, 0 maybe, and 1, 1, 0, 1, 0, 1. So this is also even number of zeros, and 1, 0, 0, 0, 0, 1 also. Otherwise no 1 also, no problem. So like that we can derive the string from the problem. Then 1, 0 also, then 0, 0, 0 maybe 1, 0, 0 also. So like that we can derive the string from the problem only. They are given the statement even number of zeros. You see here even number of zeros, here also 4 zeros, here 2 0, and 4 and 6 0 also. So like that the strings goes on. Okay. First we will check initial string, that is 0 0. It may be, suppose you are taking the string 0 0. So you have to start with starting symbol, then Q naught, then it may be 0, then it will traverse from next Q1, then 0. It may be another final state. Yeah, 0. It starts with 0 and end with 0. Now we are having the path from 0 to 0. So this string may be accepted. Okay. So in this machine, this string only accepted, that is a 2 0. But our machine will support all strings derived from this language. That is the problem. It satisfies the conditions even number of zeros. So it may be not correct. Okay. So that's why again we will try one more machines and one more machine. Finally, this machine, this automation will give, it will give, otherwise support all kind of strings. Okay. So like that we will think and we will draw as much possible, it will support for all the string. Okay. So next we will try one more possibilities. Yes. So just suppose I am writing Q naught, it start with Q0, then it may be, yeah, it traverse with the input 0, then here Q1. Okay. So suppose you are drawing the path Q0 to Q1, you will get only 1 0. When the machine which will give the even number of zeros, it may be again come back, it will give the even number of 0. Okay. Here, so start here with Q0 and reach the Q1, then again come back to the Q0. But here we are having the path, but we can't say this is accepted because we don't know which one is final state. Okay. Suppose you have to draw this as a final state. You will get even number of zeros definitely. Yeah. It starts with 0, then again come back to 0. It is one path. It will reach the final state also. Again it start with 3040 and 5060, 7080. It will pump n number, that is even number of zeros definitely. Okay, but in this constraints, suppose you are taking this string 1001. So how it is possible? That time we have to think, you can use the loop also. Yes, if you are using loop means it will generate n number of, it will generate 0 or infinity times of 1s. So that is, we can represent it as a star, that is a clean closure. It may be epsilon, then single one or double one or 3 1 and 4 1. So like that it will goes. Okay. So you may be put means this string will maybe, that is 1 0 0 1. Again it start. Okay. Next you can check here 1 0 0, sorry, 1 0, yeah, 1 1 0. Again we need one more 1. Yes, so that's why I will draw here 1. Now you check the machine 1 1 0 1 0, then 1, ended with 1. So this string also now supported. Yeah. Next you will check 140 1 1 4 0, then again 1. Yeah, 1 4 0, then ended with 1. So this string also support. So like that we will check all the condition, all the strings by use of this machines. Okay. So now this finite automata accept all the strings, that is a combination, there is an even number of zeros. They don't bother about even number of ones or odd number of ones. It started with ones or ended with ones, and also it will in between the one also come. So this is way of deriving the machine from the given the problems. Okay. So now we have to check using this transition table as well as transition functions. You have to write this Q0 initial state and also final state, then Q1. So what is the input here? 0 cents 1. What is a transition of Q0 of 0? Q0 of 0, you are getting the answer Q1, and Q0 of 1, you are getting the answer for again Q0. Then Q1 of 0, you are getting the answer Q0. Then Q1 of 1, the same Q1. Okay, this is a way of deriving the transition table through the automation, that is finite automata. Next you have to ensure whether the string is accepted or not. I am just taking this 0 0. So it starts from Q0 of 0 0. So what is the answer? Q0 of 0. Q0 of 0, you are getting the answer Q1. So Q1 of 0. So Q1 of 0, again you are getting this answer Q0. Now Q0 is final state. So now final state, starting state as well as final state. Hence the derived string by the machine, derived the string by the machine, that is 0 0, is accepted. Okay. So this is way of design the automata using the problem. Thank you.